I think it's fair to say that React kind of changed how we build applications, at the very least on the client side. It turns out that the component model and the reactivity model are a pretty good way of building. Even if you don't like React itself, that model has caught on and is being used by frameworks far away from the React world, even ones that existed before React did. But the backend hasn't seen that same significant change. While we are finding new languages and patterns and cool things to do, it feels like the relationship between backend and frontend hasn't meaningfully evolved since GraphQL. Obviously, we have cool stuff like TypeScript and tRPC, but this idea of a reactivity graph that goes from your database to the actual user loading the data, it hasn't really been unlocked. That is, it hasn't been unlocked until now, because Facebook and Meta have been working really hard. And Vuex, Christopher Chadeau, one of my favorite devs ever, just announced Skip, the reactive framework. The way he described it is, it's something like React for the backend, and it is really cool. Vuex isn't some random dev. He's the creator of Excalidraw, of Prettier, and of Recoil, which is one of the more powerful state management libraries in React. He's pretty much as deep as you can go. And when I say deep, I mean it, because Skip started as a programming language. So if you want to hear all about the history of Skip, this crazy new framework and paradigm for building, it's almost like the sequel to GraphQL in a lot of ways. Make sure you stick through this quick sponsor break. A lot of us are building dev tools nowadays, and as simple as parts might seem, a lot of it isn't. One of the things I see people getting wrong the most is API access, and that's why today's sponsor, Unkey, exists. They make building APIs way easier, handling everything from authentication to key management to rate limiting to DDoS protection and so much more. They support everything, and I mean everything. Obviously, they support TypeScript. The company's all built by TypeScript devs. But they also have SDKs for Python, Rust, Golang, using it with curl directly. Elixir, if you want to. Yes, they have an Elixir SDK. Super cool. Even Java has support. Probably should have mentioned this before, but it is fully open source, which is great, not just because you can trust the code and host it yourself, but you can actually read through and learn a lot about proper full stack open source application management, because this is a complex code base with a lot going on inside of it. When you set up APIs like this yourself, you're going to end up missing a ton of things, from how you handle multi-cloud to how you invalidate environment variables to how you manage rate limiting by keys as well as by IP addresses. It's not fun. I've been there. And if you want to avoid being there, you should check out Unkey today. Check them out today at soydev.link/Unkey. I just spent a lot of time deep diving on all of this, and I think the whole deep dive is going to end up on my other channel, Theo Throwaways. There will be a link in the description if it does. First, I have to show you guys the website because it's stunning, especially for a newer project that also isn't that new. There have been pieces of Skip floating around at Meta for a while, and they are actually using this for a lot of stuff. But Skip's an interesting framework because it's not like an alternative to Express or Nest or Next.js or any of these other things. It is a layer that goes between a bunch of backend services, data sources, whatever, and your client. Similar to how like a GraphQL service lives between your other services, your databases, your microservices, whatever, and your clients. This fits in that same spot. As they describe it, it's a simple, comprehensive abstraction for building real-time features that are efficient and debuggable. It's not an easy path there, but it definitely does do that. Their goal is to simplify your state, similar to how React solved this whole category of bugs with the graph of components. You've hopefully seen an image like this before of React as a tree. If you have the app component and it has two children, inspiration generator and fancy text, and then inspiration generator has children of its own, there's now a clear dependency tree from top to bottom. If inspiration generator had some state and we wanted that state to get to fancy text, you're kind of screwed. Because in React, the state has to live in a parent in order for the children to have access. If the child owns it itself, it can do whatever it wants with it, but nothing higher up or to the side of it has access. Only children will have access to that state. This has costs, as I'm sure we've all seen, where you move some state up too high and now everything re-renders. But we don't give this model enough credit for is how many problems it solved. It was very common before React for you to work on a feature where you click a button and then something changes, but now you have to manually tell it every place to change. Like if I hit the delete item from cart button on Amazon, now I have to update state in like 15 different places, but I don't remember to go rerun the thing that generates the icon in the corner. Even if I've updated the state properly, I might still see 13 items in the corner when I should only have 12. And that's what React basically made go away with this reactivity model at the cost of re-rendering. Now with stuff like compiler, we're solving those costs, but the model itself has its benefits and negatives. There is the cost of having to be declarative and having to rerun everything when a change occurs, but there's the benefit of you'll never have anything out of sync ever. You don't even have to define the logic for the updating because the graph itself is what defines the updates. And this absolutely simplifies our state. We've seen this in React. We've seen this with tools like React Query. We've seen this in other frameworks and spaces as well. It is very powerful. So what actually is skip? They keep using this term runtime to describe it, and it feels weird, but I think it's fair, especially when you consider the fact that it is written in a combination of their custom language, skip, as well as straight up C. Yes, 20% of this repo is just raw C, which is kind of insane. Yeah, the runtime is interesting. It's the way that you define these collections, they call them, and the relationships between them. And this skip runtime lives between external services and the application that users are actually going to consume. The TLDR of how it works is you import things like your services, streams from other places, as well as databases, all as collections. You map them in TypeScript to new collections that have the more specific things you want. So if you have a database table with all your users and you want to have your friend list, maybe, the friend list can be derived from the user table, but it is a new collection. After you've created those maps, you can create more complex logic that's all reusable from them that then gets piped to your client, which can subscribe to real-time updates. So if one of my friends deletes their account, the user table changes. That means my derived friend collection changes, which means the friend list the user seeing should change. Or if the friend changes their name, it should be able to hydrate that change all the way to the user's friend list. And that's what makes this cool. Before we dive too deep in the code, I want to make a few things very clear. First and foremost, this is one of the most production-ready things I've talked about in a while because they're actually using this for real stuff at Facebook. And this is a project that's been worked on for years. It's not some random new hobby project. It's not some throwaway thing like my way of dealing with server actions when Next.js 14 dropped. This is a real, legit project that a lot more time is going to go into. That said, I don't think almost anyone who isn't working at Meta should be using this just yet. It is refined in the sense that it can handle production workloads. It is new in the sense that it just dropped for the public, and it is not ready to be used outside of its very specific intended way. I know that because I've spent a lot of time in this repo over the last hour and a half, and it's a journey. So let's go through their mental model real quick. The two key pieces of the skip runtime are collections and mappers. Collections are sources of data. They're like the pile of data. Like just think of it like an array of things. And then there are mappers. Mappers are things that create a new collection out of a collection. It's like running .map on an array. You get a new array. A mapper cannot change the content of an existing collection. All it can do is make a new collection out of an existing collection. And when you do that, like let's say you make a friends collection out of the user's collection, there's a direct path now from the user collection to my friend list collection. It's also worth noting that a collection can be eager, so it has all of the data constantly, or lazy, so it doesn't actually bother getting the data until it is requested by something downstream. Let's look at the example from their code base. Ignore all the errors. As I said, they do not seem prepared for people to actually dive in here yet, but that's why you guys are here, so I can do the suffering. This is a fun little service. We'll start by looking at the database server. We define our skip service. We import SQLite because we use the database to get things. We have our little helper run function here. You can ignore most of that. Now let's look at the actual endpoints we're defining. This is all using Express. So we have the user's endpoint. We call service.getStreamUUID. So this is one of the interesting quirks of how skip works. You don't request /skip/stream/user/ID. Every stream comes from the same endpoint, /v1/stream/UUID. This UUID is created by skip to represent a specific instance of a specific collection. So we tell the skip service that we want the users collection, which there's just one users collection for all the users from the database. That might not be the one you want to expose to users, but in this case it is. So we get the UUID for users, then the UUID, and we redirect the user's request to localhost 8080/v1/streams/this UUID. By doing this redirect now, the user gets sent to the thing that streams all of the user data. So now if things change, they can have an event listener that catches it. The code for that's really simple. This code can work on the server or the client, anything that is JavaScript and has event source. You create the event source literally just as the URL/users in this case. That then becomes this redirected stream URL. So now we have an event source for the stream. We have an event listener for when it's initialized, which will quickly log out the initial data. We then have an event listener for updates. Whenever an update occurs, we now get the update. And that's all of the code for that. And it is actually that simple. I'll show some client examples in a bit, like in actual React code. So now we do this fetch JSON, even though it says fetch, it's actually a put. It goes through fetch, whatever, where we're updating user with the ID 123, and we're changing their name to be Daniel, and we're setting their country to UK. Let's look at that code. We have app.put here, user ID. We get the key from the parameter. We get the data from the body of this put request. So that's the thing we sent there, this body. So we have both of these. We have the key and we have the new data we want in the database. So we use our database runner. We insert or replace into the current table, which is just named data. We pass it the ID, the object, find those values, we pass them here. Cool. Typical SQL, we've all seen this. Here's where things get fun. .then, so after the database query runs, service.put users, so the user collection, where this key is the identifier, we want to update the data. This one line here is all it takes to trigger an update to anything ever that is depending on this user. As long as all things coming from that user data from the database are mapped from it, or a collection that was mapped from it, and you can see how the graph would work, where we could be 20 to 100 layers down, where this user's collection is still the original source of truth. This one service.put call then triggers all the dependencies to update. There is no code you have to write that says this table should go update, and then this thing should go update, and then this thing should go update, the way that we're used to, where I'm sure we've all written with React Query on complete of the post call or whatever. We then go and validate 15 things so they all refetch. There is none of that. And I can prove it because when I actually run this code, it does some fun things. We see the init response. So we see actually that 123 is Daniel because that's what it was set to because I ran the code before. And since the value was already set to that, no update happens. But if I nuke that default database state, we'll see the update comes in before that second get call comes in. First, we have this init call. The init has all the data that comes through on the event source being created initially. Then we have the set call. This is when we send that post call to update the user to have a different name, Daniel. We immediately have this update come through before the get call we do after even runs. So here we are getting user 123. So we're actually trying to get from the database the user that has this ID. This comes through after the stream sends the update because it is so much faster to have an existing connection send you the update. Super cool. The delete failed because one of the endpoints died. Don't have to worry too much about that, but you get the idea. The update comes through, and that is with no custom code being written, which is again the magic part. Once you've set everything up properly, which is not easy to do, the result is a change will always trigger all dependencies, all clients that have those dependencies, they'll see the change immediately. Getting there is not easy though. You have to manually define all of these layers. If we actually look at the database TS file here, for example, we'll see how these collections are defined. We have type user, which is a name and a country. The user collection is an eager collection with the key string, the value user. We have the class user resource, which implements the resource user collection. Has an instantiate helper, it takes in the user collection and returns the actual users. And from here, we set up the service. This is with no mappings, by the way. This is just one single collection. It still has all of this. So yeah, as I was saying, this is all you need to create one collection, but it's still quite a bit. And you have to instantiate the service with its initial data, its resources, and the create graph function that creates all of the dependencies, which again, here, there aren't any. But if we go to the example they have here, which is actually a pretty compelling example, we have user ID, group ID, both boring standard types. Then we have the user type and the group type. User has name, it is a Boolean for if it's active or not, and it has a friends value, which is an array of user IDs. And then there's group, which is a name, and it has a members array, again, of user IDs. Let's say you wanted to see all of your friends based on whether or not they're active, grouped by the groups they're in. That is not a trivial grouping to do here. Even in SQL, this would be kind of annoying. The logic seems pretty straightforward. You filter the group's members by one intersection with the current user's friends and also their active status. But it is not trivial at all to maintain up-to-date information in real time as like a user changes their username or their active status changes or the groups they're in change. Getting the current state to the user is not a fun problem to solve. The way they define this is using an active user mapper that takes a group ID, a group, and a user ID array. It's mapping one-to-one out of that. Takes the group and it returns user ID array, but we filter out anyone who isn't active. So the goal here is to just give you the active users from a given group. Then we get our initial data, which is all the users in all the groups. And then we create this first layer with our graph. We take all of the groups from our input, we map them with active users, which results in all of the active users for a given group. Now we can return users, input.users, actives. And now we have these two derivative collections that come from the initial data combined with the resources combined with these mappings. This example service operates over two input collections, one for users and one for groups. And it passes some resource inputs to its resource, which is a reactively computed collection named actives, which is of the set of active users in each group, as well as the user's input collection. The actives collection is the output of the state computation graph, which is produced by mapping over the input groups and filtering out users that have the active flag set. Our service wants to expose a resource, parameterized by a user ID, which can be queried or subscribed to by a client using the user's active friends in each group. So here is the filter friends mapper. This mapper, again, group ID, user ID array, one more user ID array here, because that's the final result. Takes in the UIDs, which is the user IDs from the group, and it filters ones that are your friend. So it keeps them if they're friend of this.user, and it doesn't if they're not. So this allows you to take the current user's friends and only return the user IDs from a given group that are that friends. So now we have our active friends collection that does this mapping for us. And in the instantiate, we can see how it does it. The user is input.users.getUnique with this.user ID, because this.user ID is the thing we passed here for the user we're getting the info for. And now that we have this user, we also have their friends. And we can now pass this as part of the constructor to the filter friends mapper, and it will go through all the active people, and it will map the ones that are your friends, and it knows who you are when you pass the user here. It's a bit convoluted, and the control flow isn't super clear. I think this arguably should go first, because this is what you hit, and then it passes that user that it gets the user ID for over to filter friends. It is kind of hard to mentally model because it's one of the most functional paradigms I've seen, where it has the single source of truth and it's trying to send that down through side effect free functions. But we're defining everything very OO with these classes. So it's a bit of a set of mental hurdles to jump. But when you see what it's enabling, it is very, very cool, because this admittedly hard to digest code enables us to, on the client, seamlessly request the user's active friends. And now when a user's status changes, a user's name changes, or a user's groups change, the client just sees the update with no additional code having to be written. I promised client-side code, so let's take a look at it. Here is an example for their Hacker News clone that I tried to get it running. There is no world in which this code is going to run. I am sorry. But here is the feed component. They have a pulled version here by default, but that's not what we're going to use. We're going to take a look at the reactive version. They create an event source. They have an event listener for when the init event comes through, and we set posts to be updated posts. I would name this initial posts to be a little clearer, because we have up here posts, set posts, use state, post array. So the event source, when created, fires the init, which sets the default state for posts. And then when an update comes through, it comes through with all of the posts. So we just rerun the set post function with the new set of posts. And then to make a change, we just have a post call. Confusing since we're getting posts. I mean post method call that triggers the update. And as long as the backend is implemented properly, this should automatically come through and you'll see the update on your end as a user. This is a fun example because it has three pieces. It has the www, which is the actual web app. It has the reactive service, which is the skip layer that does the binding between backend things and the front end experience. But it also has the web service, which is a Python project that is meant to be the backend for this fake app. So you can almost imagine this is how it was originally written. And then a new requirement for the app to perform better, or you're making a new mobile app and you want it to update automatically. This is how you would add that, by adding something like skip in between your existing backend or microservice layer and the front end. So for actually getting the posts to that skip layer, we have the check if event stream is supported. And if it is, we just pass you on to the event stream from the reactive service URL. And if not, we hand you a snapshot instead. We have app.post, posts for creating a post. We have all of our DB calls to actually get it in the database. But the way that we trigger the update through skip is our microservice here calls the reactive service URL /input/post post ID with what changed. So now our skip service knows that this particular collection had a new entry added to it, so it can then, through its graph, trigger the right updates for the client. Or if the user doesn't upvote by calling /posts post ID upvotes, we don't actually use the user's ID here because I don't think they have auth at all, so there's no current user. But once we have done the update in the database, we do the same thing where we call the reactive service and we tell it that there's this new upvote ID that has these properties, which then it triggers everything depending on upvotes to change too. So if the posts that you're rendering in the feed combine posts as they're stored in your database with upvotes as they're stored in your database, a change to either that affects the thing that you're consuming will trigger the update to come through. But that's the thing that I think is important to try and understand and have click with this model is when you change data, you have to do the data change. Then you have to tell Skip, hey, this is the data that changed. And then it handles all of the updates from there. In other systems, either you would not have this part at all, and you would expect the client to refetch when the change happens, or you would have this backend code hit 15 different services, invalidate like 20 different caches, and do all the things it needs to make sure everyone dependent on this data and every shape this data could be in makes its way to the client. Hopefully this helps clarify why it isn't for everyone. And what's even funnier is this is the like digested version. Previously, they were trying to ship a new programming language, and it turned out that's hard. As such, they changed the strategy. They built the core library using Skip, but they have people write code in JS instead, which has a much lower adoption barrier, but still has the same wins. So now that you've seen how high this adoption barrier is, hopefully you can estimate how much higher it was when they required you to write this in a whole new crazy language. Yeah, that's all I got on this one. It is a wild project that I'm actually very excited for. I don't think almost anyone should use this, but I think it introduces some really cool ideas that we can all learn a little bit from. Let me know what you guys think. And until next time, peace, nerds.